Today we are going to learn about isotopes of an element. So what are isotopes? Isotopes are atoms of the same element, okay, but they have different number of neutrons and mass number. Mass number can be calculated by taking the number of proton plus the number of neutron. So if you change the number of neutron, you also change the mass number. There are two common notation of isotopes, or two symbols of isotopes. The first common one that you will find is this one right here, where you have X and we have three numbers. This number on top is the mass number, which is a bigger number. Then we have a smaller number, is the atomic number on the bottom. Lastly, we have a net charge of an isotope. Sometimes an isotope has a positive or a negative charge. Let's look at the values of a number. First of all, let's look at mass number. Mass number can be calculated by taking the number of proton plus the number of neutron. Then here we have the atomic number. The atomic number is equal to the number of proton. If we know the symbol of an element, we can look at the periodic table, okay, to determine the atomic number, because each element has a unique atomic number. If we know the symbols, we can also know the name of an element by looking at the PT. Lastly, we have a net charge of an isotope. To solve for the net charge is basically you take the proton minus the electron. Based on this notation of an isotope, we can find so many information about this particular isotope. So another notation of isotope is this one right here. Here we have X represent the symbols or the name of an element, which can be found on the periodic table. Okay, so PT again. Then we have hyphen and a number. This number is the mass number, which is equal to proton plus neutron. In this example, we have three common isotopes of carbon. We have carbon-12, carbon-13, and carbon-14. Then we have the isotope symbols for each of the carbon isotopes. So if we look at this picture, one thing we realize that the number of protons stays the same throughout, right? Because each proton number determines the element. So the element has to stay the same. And the only way they stay the same is the atomic number stays the same. But if we look at the number of neutron, the number of neutron changes. One here, it has only 6, right here it has 7, and then it has 8 right here. So therefore, the mass number also changed. So again, I rewrite the common notation of isotopes, carbon-12, 13, and 14. So let's apply the information we learned about isotopes. In this task, we are going to determine the isotope symbols from the following information. It gives you proton equal to 6, neutron equal to 6, and the net charge equal to 0. We have to determine the isotope symbols based on this format right here. So first of all, the proton will give you the atomic number, which gives you 6 right here. And then if we know the number of neutron equal to 6, we take the proton plus the neutron, give you 12, that would be your mass number right there. Then over here, the net charge of an atom is 0, so we just have that. So therefore, our answer is basically just carbon 12, 6, 0, or just C12, 6, or we can have carbon 12 like that. So these are the possible answers that we can get from this information. Here we have another example. We have neutron equals 7, mass number equals 13. We have electron equal to 6. Again, we are looking for the isotope symbols given in this format right here. First of all, we need to determine the mass number, which is 13 right there, right? So 13, that was easy. And then we have the atomic symbols, which is not given to us, but we have the mass number and the neutron. Based on the equation for mass number, proton plus neutron equal to 13, we can substitute in the neutron, which is 7, and we solve for proton. So proton is equal to 13 minus 7, give you 6. And this 6 is your atomic number, which is also your element symbol on the periodic table. So here we have mass number 13, atomic number 6, and we have carbon as our atomic symbol. But how do we figure this out to be 0? Going back up here, we have our electron equal to 6. So plug into the equation, net charge is equal to proton minus electron. 6 minus 6 will give you 0. So that is how we know that the net charge is equal to 0. Let's try another example. We have neutron equal to 8, mass number equal to 14, net charge equal to -1. So we want our symbol to look something like this. This is our mass number, which is given to us, 14. And this is our atomic number, which we don't know. But we know that mass number equal to proton plus neutron. And we know the neutron, right there. So we plug it in. But we don't know our proton, but we know a mass number, which is 14. So protons equal to 14 minus 8 give us what? 6, which will also equal to your atomic number as well. And if we look at the periodic table, the element with atomic number 6 turn out to be carbon, which is represented by the letter C. Then we have our final answer, as in the symbol C represents carbon. We have our mass number is equal to 14. Then we have the atomic number equal to 6. But what about the net charge? The net charge is equal to the -1. Let's bring this a little further. If we know our net charge, can we find the number of electron? We know that net charge is equal to proton minus electron. So if we look at this closely, we can say, hey, my net charge is equal to -1, and I know my proton is, in this case, is going to be 6, but I don't know my electron. We can use basic algebra to solve for electrons. See how this is minus electron? So we add electron on both sides, add electron on both sides. This cancels out, so we have electron minus 1 equal to 6, and therefore number of electrons is equal to 6 plus 1 give us 7. That's the math, that's the algebra way to solve for it. Or you can ask yourself, 6 minus what will give me -1? And the answer is 7. And therefore this one is 7 electron. Either way is fine.